This question is more of a physics question really than a maths question, but it is on the IGCSE. It involves a particle which is moving in a straight line. So when we have things moving in a straight line, we have velocity rather than speed, because velocity is speed with direction. We have a time t seconds, displacement, so that is distance in meters, which is s, given by this formula here. So one of the things to look out for is s here is distance, it is not speed. So distance is equal to this formula here. We want to find the minimum speed. You get a question like this, the first step is always going to be to differentiate. We're going to use v for speed, because v stands for velocity. And velocity is our change in distance over change in time. If you think about it, speed is miles per hour or kilometers per hour. It's the change in the distance divided by the change in the time. So we can just do ds by dt, differentiate our equation here. So differentiating t cubed, that's going to give us 3t squared. You should know that the power comes down in front, and we take 1 off the power. Then we have minus t squared, so the 2 comes down to multiply the minus 9, giving us minus 18. 1 off the power gives us t to the power 1, which is just t. Differentiating 33t, you just get the answer of 33, so it's plus 33. And when you differentiate a constant, in this case minus 6, it just disappears, so there's nothing to add on here. So this is the equation for our velocity or our speed. We want this to be the minimum possible. You cannot do that from this form. We have two lots of t, and it's far too complicated. So what we'll do here is we will complete the square, because that will give us just one value of t, and then we'll end up with a formula we can make it as small as we can. So completing the square here, the difficulty with this is we don't have t squared, we have 3t squared. Now I could look at the whole thing, because the whole thing is multiples of 3, but I'm not. I'm just going to look at this here. I'm just going to change this bit here, leave my plus 33 alone. So my velocity is equal to 3 multiplied by t squared minus 6t plus 33. So all I've done here is I've factorised just the 3 out from both of these, give me t squared minus 60. This, then I can complete the square very, very easily. So I'm going to go 3 square bracket, that's going to be t minus 3, so it's half of the 6 squared, and minus 3 squared is 9, so I'm going to have 9 more than I need, so then I subtract my 9, close the bracket, and then my plus 33 is outside of all of this. So all I did here was I just completed the square with this, which is equal to this. Now I need to expand and simplify. So I have 3t minus 3 squared, minus 3 times 9 is 27, so minus 27, and then plus my 33 at the end. And that then becomes 3t minus 3 squared, and then plus 6, and that's my finished form for my velocity, having completed the square. The reason I've done this is I want this to be as small as possible. For this to be as small as possible, this bracket has to be equal to 0. If this is 0, 0 squared is 0 times 3 is 0, so my answer will just be 6. So to make this as small as possible, I'm going to make t equal to 3. So v minimum when t equals 3. I'll just write it straight down. So now I know my minimum value of time, I need to know my the minimum speed. So now worth at this point just checking which formula I'm going to use, because depending on the question, sometimes we go back to the original formula. In this case, it's minimum speed. So this is my speed formula here, velocity is the same as speed. So my 3 goes into this equation here. So my v minimum when t is equal to 3. So I do v equals 3 multiplied by 3 squared minus 18 times by 3 plus 33. And as you can see, I'm replacing my t each time with the value of 3. And if I work that through, I get 3 squared is 9 times 3 is 27, so it's 27. Minus 18 times 3, which is 54, plus 33, and I get the answer then of 6. So the minimum speed will be 6 meters per second, and the units will probably be on the question on the answer paper anyway, so they're looking just for the answer of 6. So in review, when you've got a question such as this, they're looking at displacement and so on. We want the speed from that formula. Differentiate first to find the minimum from a quadratic. What you need to do is make sure you have completed the square. To complete the square, you need to have it in this form first. So for example, t squared minus 6t. So there's quite a bit of work here to go through, quite a few skills involved. And once you get to your completed form, then you work out the minimum value and then check which formula do I want to use, go substitute that back into. Do I want the minimum speed, which is this formula, or do I want to know at what time is it at the minimum speed, in which case I would have put it into, what distance is it at the minimum speed, then I would put it into this equation here.